So we've been talking a lot about models for computer vision, models for image recognition, or whatever. It turns out that you can take a lot of this same machinery and apply it to models for natural language processing tasks as well. And so one other big thing that we've been thinking about in our group is exactly understanding what we can learn about what current models for natural language processing, and especially models that automatically generate language, what those models are actually learning about the world. And what's interesting about this is, it's obviously important for sort of practical deployment scenarios and figuring out whether text generation systems that we have today actually work or under what circumstances they work. But it also starts to let us answer fundamental questions about the nature of human language itself. There's a sort of ongoing scientific conversation about the kind of data that, for example, a child language learner needs to understand language, right? How important is it to be in a social context? How important is it to be interacting with the parents or other adults that are speaking to you? How important is it to, sort of understand the perceptual context and have things pointed at and gestured to and, objects to refer to and things like that. Now, obviously it's the case that current natural language processing models are not learning language in any way like human child language learners, right? They are, for the most part, just trained on giant data sets of text, mostly scraped from the internet, without any of this sort of rich context in which human language learning takes place. And as a result, there are all kinds of open questions about how much you can actually learn about how language works, period, from text, and just text. And using some of the techniques that we've developed, things that are sort of related to this Milan method, we've actually been able to show that you can acquire, certainly not human-like representations of meaning or human quality representations of meaning, but still much more about meaning and much more about the way language works than I think was previously believed could be learned just from text data. So, in addition to identifying things that current systems can do or things that current systems have learned that was beyond what we expected them to be able to do, we have, of course, also identified a number of ways in which the kinds of representations of language that current models are building differ from the kinds of representations of language that we believe that people build as they're learning language. And so something that we're starting to do now is figuring out, with this sort of richer understanding of what models know and don't know about language, how can we actually improve the ways in which they're trained in order to make them better at processing language. And so we have some work going on right now showing that with very small amounts of extra targeted training data that sort of shows to these models exactly the piece of language understanding that they seem to be missing right now, you can very sample efficiently improve the quality of their predictions.